In this video, I would like to begin observing and even deriving some properties of logarithms that will help us later as we solve logarithmic equations and as we evaluate logarithms. The first two properties I'd like to look at simply stem from the definition of a logarithm. If I write the first two properties in their exponential form, we will see that b to the power of 0 equals 1. We already know this to be true, a zero property of exponents. What we see over here as the property of logarithms is simply the logarithmic form of this equation. In a similar way, for number 2, log b of b equals 1, this is true because think of its exponential form, b to the power of 1 equals b for any base b. The third and the fourth property here are known as inverse properties. Remember that a logarithm and an exponential function are inverses of each other. And that should mean that a logarithmic function composed with an exponential function always equals the identity, because we know from earlier observation an inverse composed with its original function is equal to the identity. I also want to show some reason why these are true though, some proof of these for number 3 and number 4. So let's take number 3 and let's say log b of b to the x is some output value y. We don't know yet what it is. What are we saying here? If we convert this to exponential form, we are saying b to the power of y, the base to the power of the output value, equals the input, which is b to the x. Well, if b to the power of y equals b to the power of x, that is only true if y equals x. Therefore, going back to our original statement, log b of b to the x must equal x. We also have the property that b to the power of log b of x equals x. Let's try to show that. Let's take that exponent piece, log b of x, and we're going to say that that equals some output value y. If we convert this to its exponential form, what we're saying here is b to the power of y equals x. Well, that's exactly what we have written here as number 4. We've just written it in the form b to the power of log b of x equals x. So these 4 properties can be useful with logarithmic functions of any base, including the common and natural logarithms. I would like to extend these properties to the natural logarithm because we will use it often in solving equations. And I'll leave it up to you to extend these properties to the common logarithm as well. So, what's the natural logarithm equivalent of log b of 1 equals 0? We would say natural log of 1 equals 0. Second, we're going to say natural log of e equals 1. Remember, the natural logarithm is log base e. So we're simply saying here in number 2, log base e of e equals 1. Third, we are saying natural logarithm of e to the x equals x. And fourth, we are saying that e to the power of ln of x equals x. So these are the same 4 properties, they're just written in terms of the natural logarithm. You could take these same 4 properties and rewrite them in terms of the common logarithm as well. Finally, let's look at just a few examples of how we can use these properties to simplify some expressions. So what is log 5 of 5 squared? Well, this is property number 3, log b of b to the x equals x. That means log 5 of 5 squared equals 2. Log b of b to the x equals x. What is natural log of e to the fourth? From our third property above, we can see that ln of e to the fourth is equal to 4. What is log base 2 of 2? Well, log b of b is always equal to 1. And finally, what is e to the power of ln of x squared? E to the power of ln of x squared should equal x squared. Our input here should be equal to our output here because of property number 4 above.